Good morning, students. This is for Pharm.D students, second year, Pharmacognosy and PHYTOPHARMACEUTICALS for the students of Pharm.D, Sri Krishna College of Pharmaceutical Sciences and Research, Center Parashala, Trivandrum. And especially we are going to discuss about alkaloids, specific what all the drugs which we have seen in the lab. You might have your own manual, but it will not be sufficient. You have to refer more, and even my notes or my lecture may not be sufficient. You have to refer more as you are a Pharm.D student, doctor and pharmacy students. You need more about the natural drugs, how it is applicable for therapeutic action and their pharmacological action, therapeutic application, and the formulations also very important for you to know about the drugs from in nature. So you can have anytime, you can mail me or you can contact the following number and you can clear your doubts, and also you can use my Pharma DXP at DX Prasad YouTube channel, and you can subscribe so that you will get all the classes which is related to pharmacy, not only for Pharm.D and other classes with MCQs which may be helpful for you to revise your knowledge in other subjects also. So kindly subscribe to my channel and then you can get the classes in updated. So today we are going to discuss about alkaloids, not directly to the drugs. We should know, because for Pharm.D students the question pattern is 10 mark and 5 mark. So if they ask what is alkaloids in a 5 mark or a 10 mark, you cannot write directly the examples of alkaloid drugs which you have seen like Datura, Syncona, like that. If you write start, you will not get the full mark. So you should know about what are alkaloids and what is its classification, some examples, whichever, because if you read more and then you can write, you can write at least some of the things. If you leave also, some examples are more needed. While evaluating, we know what the students are doing mistakes. So you see alkaloids, this is simply a picture to show you. Alkaloids are present in coffee, tea, like caffeine is also alkaloid. That's why coffee I have shown. Morphine, very common injection, it's pre-operative pain. It's a narcotic drug, analgesic drugs, and it's just a flower of the opium, poppy flower. And chocolates which contain most of the theophylline, theobromine, they are all present as an alkaloids. And codeine syrup, which we know, that's why these some pictures which I have shown before going to an alkaloid definition. So when you talk about alkaloid definition, it is difficult to define such that. Why? Because no definitive difference between an alkaloid and a natural occurring complex amines. So you should have a basic knowledge about your chemistry, what you studied, amines. Amines means you might have studied about NH2, RNH2, primary amine, secondary amine, tertiary amine, quaternary ammonium compound, and amides which are containing nitrogens. You might have studied as a functional group, maybe aromatic, aliphatic. So complex amines and an alkaloids are having a similarity. So that's why we said, but still alkaloids can be defined as plant derived or alkali and contain an at least one nitrogen atom, N2 atom. They also normally have a significant physiological action on human beings and animals. They are secondary metabolites which is present in the plant source, alkaloids. So they have nitrogen. You can see this one, a pyridine structure with a benzene, it's an naphthalene or nitrogen which is present inside the ring, or a 5-membered ring with nitrogen and a 6-membered with nitrogen which is present mostly in the the indole alkaloids which is joined together, but you can see in nicotine also this structure. So there are proto-alkaloids, amino-alkaloids, amino acids, which is containing amino acids. Why it is called amino acids? Because it contains amino group and acid. That's why it is called, you can see deuterions, they have positive ions and negative ions. So they are amino acids, building blocks of proteins in our body. So these amino acids also present in the plant amino acids. They are responsible for various biosynthetic pathway. So alkaloids, they are secondary metabolites, metabolic pathways, metabolism, biotransformation. These are all things you might have studied in the biochemistry and other previous subjects. So you should know, you should revise the basic knowledge when a lecture you are listening. That is very, very important. Pharm.D students especially, I am repeatedly telling you have to update yourself. Otherwise we cannot stand in the competitive world. Pharm.D is one of the course or one of the course which is after completing is the highest paid course in Europe and US. Even in India, it's possible to come to, and we should find an opportunity to where to place this Pharm.D students, and it will be soon. Even we will make it sure that is you will get a very good opportunity over this pharmacy field. So you should update. Not only getting the opportunity should be sustained, and the people should recognize you know something. That is important by means of updating yourself. So amino alkaloids, why it is called amino alkaloids? They are having nitrogen. Nitrogens are the base which may be present in the, it is usually present in amino acid. Applied compound which lack one or more of the property of the for the alkaloids, they are called as proto-alkaloids or amino-alkaloids. They are also, we can say. Other alkaloids which do not conform with the general definition are synthetic compounds not found in the plant, but they are closely related to natural alkaloids. There are many synthetic alkaloidal products also available. This is general definition, but when you come to a classification, you will mainly the student should know alkaloids are basic in nature because presence of nitrogen. They may be inside the ring and maybe outside the ring also may are present. Or you can say they are heterocyclic rings which is present. Contain nitrogen usually derived from amino acid. Bitter tasting, generally white solids. Exception you should remember, nicotine, which is present, is a brown liquid. Even it can be volatile in nature they are. They give a precipitate heavy metal iodides, that you have to remember. All alkaloids, exception for caffeine, is a purine derivative, does not precipitate like all alkaloids. But it is an alkaloid, purine alkaloid in nature. Purine means you may be there is 4 nitrogens will be present in a 6-membered and 10-membered and a 5-membered ring structure together. Purines you might have studied. Adenine, guanine, cytosine, which are the building blocks which are the present in the DNA molecule, and they are present in the proteins. So you should know that caffeine is a purine derivative which contains 3CH3, that is 357CH3 alloxon, or it's a purine derivative. Alloxon also purine derivative, which is when you see in the chemistry you might have studied, basically they are purine derivatives of xanthine derivatives. Xanthine is a basic structure for caffeine, theophylline, theobromine. Caffeine is also, but they did not give precipitate with the iodides. Chemical test they may not give you, but they are alkaloids. Nicotine, as I told, it is also present in tobacco, which is a stimulant, CNS stimulant, and ganglionic acting drug. You might have studied in pharmacology very clearly the ANS. So cholinergic, anticholinergic, adrenergic, anti-adrenergic, or cholinomimetic, or cholinolytic, or sympatholytic, sympathomimetic, like that. You might have studied various words and various definitions from the pharmacology, very important for the Pharm.D students to know. So caffeine is a structure, as I told, it is also, you can see it's a xanthine derivative which contains double bond O, apart from which is not present in the purine. You might have seen purine will be having 4 nitrogen, but the double bonds will be removed by the substitution of double bond O and CH3, which is shown in the structure of caffeine. Theophylline, theobromine, they are all changed the xanthine derivatives by means of presence of number of CH3, and also the position will refer the structure of this theophylline, theobromine and caffeine alkaloids. Alkaloids are basic. They form water-soluble salts. Most alkaloids are well-defined crystalline substances which unite with acids to form salts. That everybody knows. If it is a base, when you add acid, it will become salt. So solubility, it can be soluble in water soluble, can be made into a salt. In plants, they are mainly exist in free state. They are in salt, not in salt form. Sometimes it is free state, sometimes in salt form, sometimes it's N-oxide form in the plants naturally. Occurs in a limited number of plants. Nucleic acid exists in all plants, but alkaloids occurs in very few plants, whereas morphine exists in only one plant species. Why we want to specify that? Sometimes some alkaloids are present in the different species coming in the same family, like atropine. You can say hyoscyamin, atropine, they are present in Solanaceae family, belladonna, datura, and they are all present in that Solanaceae family. You can see that atropine alkaloids are present in different plants in the same species. But if you see in Papaveraceae family, you can see only present in opium. Papaver somniferum will contain morphine. So that's what specific species only contain morphine. Test for alkaloids. Most of the alkaloids are precipitated as just now we are told iodide salts, neutral or slightly acidic solution by Mayer's reagent. You can see that, especially you should know that what is the chemical name of the Mayer's reagent. Simply writing Mayer's reagent will give creamy colored precipitate or white precipitate. If you write, it's not the right way to write a pharmacist especially. You should know what is the chemical substance present in the Mayer's. Mayer's is a scientist name. What is the chemical? It's an iodide. So it's an iodide metal, they will get precipitate. Just now we have seen in the last slide. So potassium mercuric iodide solution is Mayer's reagent. When you add with alkaloid, they show creamy colored precipitates like this. Sometimes white or sometimes yellowish. Drag and draft reagent, it's a very important reagent which gives precipitate orange color precipitate solution of potassium bismuth iodide. What is the drag and draft reagent? Means solution of potassium bismuth iodide. So you can get an orange color precipitate. And Wagner's reagent, iodine in potassium iodide. So red brown precipitate like this it can be obtained. Hager's reagent, it is a picric acid which gives picric acid gives yellow precipitate as shown in the picture. Caffeine does not give any precipitate for this iodide salts just now we have discussed, but it is an alkaloid. Understand that you have to remember. These type of specific differences the student should remember. Occurrence and distribution, location of the plant of the alkaloids, just a slide which I made because some plants, whole plant contain alkaloids. Sometimes where it is occur, which part. So usually when I come to the lab, I used to say first the student should study the biological source in such a way, which part of the plant is having the constituent. Like when you say Cinchona officinalis, if you simply say Cinchona officinalis, Cinchona legionella, and it says family, if you say it belongs to Semarobiaceae, if you say, it's not the right way. You should say dried outer bark of this Cinchona officinalis, which is specifically the bark we are using for Cinchona. So sometimes if you are writing Datura stromanium, you can say the whole plant, but you can see the belladonna, the whole plant, but in Datura stromanium you can find more active principle in the leaf. So leaves of Datura stromanium and senna also, but senna pods, that is different glycosides, but I am just giving the example for alkaloids. So occurrence, even not only plants, it can be occurred in the even microbes. Say like you can see Pseudomonas aeruginosa occurs in bacteria also. They are rarely in fungi also. Psilocin and halocin, and even mushrooms. Hallucinogenic mushrooms also, they have alkaloids. Some alkaloids occurs in several genera like species caffeine, which in several species like tea, coffee, they all contain caffeine. theophylline, theobromine, coffee in the seeds, tea in the leaves, so like the different species. Some occurs in the family like hyoscyamin, just now we told like atropine. Hyoscyamin is the other version of the atropine name. They hyoscyamin and atropine are same. Only thing is they have an isomers. They are different isomers. Hyoscyamin. Usually in the nature they are present in a racemic mixture. Hyoscyamin and atropine, because they have a chiral carbon atom. They have L and D configuration. That you know very well. When a carbon atom is having different atoms attached, they will have their rotation, the plane of rotation. So that two of them, hyoscyamin and atropine, this also should be remembered by the students. So they are present in the Datura stramonium and belladonna and Datura, this metal, they all contain this hyoscyamin, and they are coming to the Solanaceae family. But if you see morphine in a specific species of Papaver somniferum, only it contains this morphine. So rarely do plants contain more than one type of alkaloid. Usually plants are one type of alkaloid present in one plant. And all alkaloids of one plant will have a common biosynthetic origin. What do you mean by biogenetic or biosynthetic? Biogenetic you can say, because biosynthetic, the word when you say, students may say it is synthetic, but biogenetic word you can say that is biogenetic. Automatically even we have biogenesis, biotransformation, biogenetic pathways like cyclamic acid pathway, mevalonic acid pathway, and you can have the acetate pathways and amino acids, aromatic amino acid, aliphatic amino acid, which are responsible for various secondary metabolic products production in the plants. So plant biochemistry also very important. Biogenetic origin, the many alkaloids occurs. Alkaloid occurs in all plants. Parts actually. Which part? All parts. Some of the plant, but it usually localized in the bark, seeds in some plants, which the plants are widely usually contain other parts may not be contained, only particular parts in some plants. Occasionally different alkaloids also in different parts of the plant, especially in vinca flowers. You might have seen this one. Even when I was asking in the class, the student was telling very clearly this name in Tamil they told Nitya Kalyani, and even in Malayalam also the same, but it is actually we are told vinca, and we will say this one is an anti-cancer drug, but the quantity of the active principle is very less. Just an example I have taken, vinca is a prinkle which you have to take anti-cancer effect. Only 3 grams is present in 1 ton of leaves. Just imagine, in 1 ton means you can see 1000 kilograms can give only 3 grams of active principle. What is the active principle of this vinca rosaceae? Apocynaceae is the family. The leaves of the vinca rosaceae, Apocynaceae family, they contain vincristine, vinblastin. They are anti-cancer drug. So the nitrogen of alkaloids which is present in alkaloid, general alkaloids, may be primary, secondary, tertiary or quaternary ammonium compound. So you know very well, you should have the base of the chemistry, you have to revise. At present I have given some idea in the class, but now it's a lecture which is needed for the examination point of view. Sometimes some students will have a habit of listening to the lecture. Listening will have very important for them to write, because you have to express the language is very important. You have to listen, and then only it is possible for you to write. So you can see the nitrogen which may be present in the alkaloids may be primary, secondary, tertiary or quaternary ammonium compound. The nitrogen feature affect the alkaloids derivatives which can be prepared and isolation procedure. So here already you might have studied, your teacher might have told about extraction, isolation, separation. Here also I have given some clue, some of the short point of the things which student can remember to write. Suppose if they are asking an essay question, you should write how to extract, how to isolate, and what all the solvent system can be used, and what is the procedure which can be followed for an alkaloid to be extracted from the leaf or a root or a stem, or according to the whole plant, according to the situation which is present in them. So alkaloids, physical and chemical properties of alkaloids, it's just a running slide which we know that molecular weight differs from 100 to 900, and most of the base which do not contain oxygen the liquid in room temperature, example nicotine from nicotiana. That means you should remember that tobacco, which you can give nicotine, and it is a liquid, while those others, all of them are solids. In rare cases they are colored. Most solids rotate in plane rotation. They have D and L rotation because of their presence of carbon atom with chiral carbon atom with different. They have an isomeric system can be seen. Polarized light, they will rotate in R and L configuration, or you can say right and left, or you can say that is levorotatory, dextrorotatory, can be obtained by means of presence of chiral or chiral carbon atom. You can pronounce in the two ways. So they have high melting points and normally are not soluble in water, occasionally slightly soluble some of the alkaloids. Soluble in apolar, that means non-polar solvents, or apolar solvents, that means low polar solvents. So solvent system should be always, you should remember. You should remember, or you have to write, and it should be in your fingertip actually. No need to confuse these low polar solvents starting from hexane, petroleum ether, benzene, acetone, methyl acetate, and then comes you can see ethanol, methanol, and water last. That is a polar, and even high polar means dilute acids like dilute HCl, dilute nitric acid, dilute sulfuric acid, like that. You can go for high polarity of the solvent system. You should always have a list of solvent system. That is organic solvent and slightly soluble in polar organic solvent, soluble concentrated hydroalcoholic solutions. So the basicity of the alkaloids depends on the availability of the lone pair of electrons present in the nitrogen, because you know very well, donating electrons, well, the basicity depends upon the electron donating groups enhancing the basicity, while E withdraws, the group decreases it. So because some alkaloids have a carbonyl group on the amide, because amino acid you have the carbonyl group, COOH group or C double bond O group, maybe a ketone or aldehyde or an acid. They also be neutral like colchicine, piperine. You have to remember the chemistry, what I am saying, listening and just remembering about what is carbonyl group. My teacher told about ketone, aldehyde, acid. So you should remember RCH, RCOOH, RCOR, ROR means what, RCOR means what, RCHO means what. That is what, aldehyde, ketone, amide. These all things you have to think about, the basic things. Then it will be easy for you to know. So that you can see sometimes amide carbonyl groups which may present, it will cause neutral also, because of amine group and carbonyl group, they may have a neutral. Basicity is also influenced by the steric constraints, stereochemistry, like configuration, that is polarity or not polarity. What I told is polarized light when fall in a chiral carbon atom present in the structure of an alkaloid will have a rotation in a D or L, and even stereochemistry can also be seen in certain alkaloids such that trans or bis or trans, like geometrical isomerism, that is structural isomerism. These all things can also influence steric constants also may be there. The basicity characters renders complex alkaloids unstable, so that in solution they are sensitive to heat, light and oxygen. So you see, these are some of the points the student should listen, and you can have a hints in your mind. It's not possible to write all the 100%, but at least you can write something, characters of the alkaloids. You may not do mistake. Understand, the basic character of alkaloid also allows them to form salts with mineral acids such as hydrochloric acid, nitric acid, sulfates like sulfuric acid, and inorganic acid like tartaric acid. Sulfamates may also make salts. Alkaloid salts are soluble in water and dilute alcohol. And the solid salts can be conversed or conserved well and are common commercial form of alkaloids which is available in the market. Naming of alkaloids also, you should know some of the names, not all I have taken. Numerous methods can be used for naming of alkaloids. Like you can see generic name like atropa, that means atropine alkaloid, tropane alkaloids, atropa belladonna. From the name itself, they have been atropine is present in atropa belladonna. And the species name cocaine is present in Erythroxylum coca. And the common herb emit the ergotamine, which is an abortifying agent which is present in ergot, and it is even for migraine, it is one of the choice of drug which is ergotamine, and which is from ergot plant. And physiological action emetin from emesis which causes, and other like morphine you can say derived from a Greek goddess, which is because it's the oldest drug which is used for various ailments, not only for sedation, not only for hypnotic sedation and to relieve pain or narcotics, but it has morphine. Even it is one of the choice of drug in before 3000 years back. It was one of the plant which was most commonly used by the human being for various ailments. Even see in cholera, if there is diarrhea, dysentery, this opium alkaloids can have a very good influence towards this type of action towards reduce the diarrhea, or the intestinal movement can also be controlled by them. So morphine, codeine, these all are some of the very important drugs, and the picture which is shown is the Greek. You know the Greek history and the Greek culture which brought lots of language as well as the culture made a lot of medicinal uses. So that's why the goddess picture, and also this is narcotic analgesic like morphine and codeine, that is methoxy morphine is a codeine, but immediately the action is totally different. Codeine is not a narcotic, it can be used for a cough syrup, it can be used as an antitussive, but morphine is a sedative and hypnotic, and it will give you, it's a narcotic drug which is not cultivated without the permission of the government. And the classification of alkaloids, when you see alkaloids have a large variety in their botanical and biochemical origin. In chemical structure, the pharmacological action, therefore, like flavonoids, and a range of different classification systems exist in a group of alkaloids. They can therefore be classified according to their biological origin and chemical structures due divisions, like a typical non-heterocyclic with nitrogen atom heterocyclic alkaloids, proto-alkaloids or biological amines, and typical or heterocyclic alkaloids. So biosynthetic pathway also can give you a rise of classification of alkaloids which is shown in the picture. You can see that the plant, the amino acid like ornithine, tyrosine, tryptophan, pyridine and even lysine give rise to various alkaloid subdivisions. Like ornithine is a biosynthetic pathway which can give rise to tropane, pyrrolidine, that is 6-membered ring with double bonds, and pyrrolizidine also is there, and also tyrosine can give rise to benzyl isoquinoline derivatives. Tryptophan can indole quinoline, indole alkaloids, quinoline alkaloids, and pyridine can give pyridine alkaloids, and lysine can give rise to an aliphatic amino acid can give rise to quinosilidine alkaloids and piperidine alkaloids. This is some of the things which you have to remember. And true alkaloids, proto-alkaloids and pseudo-alkaloids, very clearly in this picture it is very clearly explained, and I will explain in the other slides repeated, but still the student can very easily, as a hint, it is very easily you can understand and remember by means of this picture. That means true alkaloids, they have heterocyclic ring structure with nitrogen, and the proto-alkaloids also does not have heterocyclic ring with nitrogen. But what is the similarity for both of them, proto-alkaloids and true alkaloids? They both are derived from amino acid. But pseudo-alkaloids have heterocyclic ring with nitrogen but not derived from the amino acid. So very clearly a student can write this definition so easily, and he can explain even a half of a page if they ask. So heterocyclic alkaloids, example pyrrolidine alkaloids, piperidine and pyrene alkaloids, pyrrolizidine alkaloids, tropane alkaloids, quinoline alkaloids, isoquinoline alkaloids, opium alkaloids, and aporphin alkaloids, norluphenane alkaloids, ipecac alkaloids, indole alkaloids, indozolin alkaloids, imidazole alkaloids, purine alkaloids, proto-alkaloids, and also steroidal alkaloids and terpenoid alkaloids. So you can see chemical classification, again I have repeated, this is the most acceptable way of classifying alkaloid by a basic dependence, basically dependent on the ring structure present in the alkaloid. The alkaloid drugs are broadly categorized into two, especially division like true alkaloids subdivided into 12 groups, and proto-alkaloids are biological amines and pseudo-alkaloids. So just now we have seen in the picture, I told all the three can be easily remembered by the student. True alkaloids derived from amino acid and they share heterocyclic ring with nitrogen. These alkaloids are highly reactive substance with biological active even in low doses. True alkaloids, for example, which we have seen like pyrrolin or pyrrolidine, high grain cocaine species is an example. Pyridine and piperidine, you can see aracholine, anabasine, conin, and trigonilin. And that is pyrrolizidine, example, isimidine and semiphytin. And tropane alkaloids, which is the chemical structure piperidine, and that is 5-membered ring and a 6-membered ring, totally 7-membered ring structure will be there in an tropane alkaloids, N-methyl pyrrolidine, and that is atropine, hyoscine. And quinoline, quinine, quinidine, cinchonine. So you say isoquinoline, morphine and codeine an example. Aporphin, that means example, reduce the isoquinoline like boldin, and indole alkaloids are benzopyrrole alkaloid, vincristine, ergometrin and reserpine are the example. And indozolin, pilocarpine, isopilocarpine, and norlupinane example, that is cytosine and spartine. And purine, pyridine, indozolin example, you can say caffeine, theophylline, theobromine. They all comes in that category, but they will not give you the chemical reactions of reacting with the iodide salts. Steroidal alkaloids, cyclopentano, perhydro, phenanthrene ring structure, solanidine and conicin is an example. So pseudo-alkaloids, which we have seen already the definition in the structure and the hints, the same thing I have explained. Pseudo-alkaloids are a compound, basic carbon skeleton in which not derived from the amino acid, diterpenes, acotin and aconine. Proto-alkaloids are compounds in which nitrogen atoms are derived from amino acid and is not the part of heterocyclics. Such kind of alkaloids include compounds derived from L-tyrosine and L-tryptophan, alkylamines, amino alkaloids, ephedrine, colchicine. So there is this classification. You can see phenyl, ethyl amine, examples ephedrine, mescaline, hordenine, ephedra species, which is used for asthma. So you should know the pharmacological use, very important for the Pharm.D students. Tropane alkaloids, colchicine, colchicum species, gout it is used, modified triterpene, taxol, taxus species, anti-cancer drug. And in heterocyclic alkaloid, mononucleic heterocyclic ring alkaloids, specifically you can say pyridine, derivative lobelia and lobelia species, it is used for asthma. And piperidine is an example which is present in piper species, gonorrhea, antioxidant activity. Pyrrole and high grain is the example, and it's present in coca species and CNS stimulant. And you can say pyrrolidine, nicotine, which is the liquid alkaloid, tobacco species, CNS stimulant. Imidazole, pilocarpine, pilocarpus, species which is present in it is used for contraction of pupil. And polynucleus heterocyclic alkaloids, isoquinoline example, morphine, papaverine, opium species, and narcotic analgesic they are. And quinoline and quinidine is present, is an example which is present in cinchona, which you studied in the lab, and anti-malarial drug. And you can see, but quinidine you can use for fibrillating agent and anti-arrhythmic drug actually. And indole alkaloids, you can see ergotamine, reserpine, vincristine, strychnine, which is present in the naxomic acid which you studied, like ergotamine present in ergot, reserpine present in raulfia, vincristine present in vinca, and strychnine which is present in naxomic acid. So these all things you have to have an example. What is the use of ergot? Oxytocic effect, and it can be having these all you can see an anti-hypertensive drug like reserpine. Anti-cancer drug is vincristine, vinblastine, and you can say CNS stimulant is strychnine. That is what which is given in the column, which is easily the student can identify what is the uses which is mentioned in the tabular column. And you can see the quinosolin example is vasacin. Vasacinone is present in Vasaka leaves, which is used as an antitussive. Most very commonly the syrups are available. Tropane alkaloids example atropine, hyoscine, and atropine, hyoscine, they both are isomers, but hyoscine is having one more lactone ring which will be present like scopolamine. Datura example and belladonna which is present in the species. And what is it? It's parasympatholytic therapeutic activity. Purine derivatives, caffeine, theophylline, theobromine, they are present in coffee and tea. They are CNS stimulant. Steroidal drug and solosodine, which is present in solanum species, example steroidal precursor, they are used as a steroidal precursor. Terpenoid drugs, which is polynucleic heterocyclic alkaloid, which is present in aconitin and aconite species, and it is used for neuralgia. So now we are coming to the extraction of alkaloids. We have to go very fast because already you know very well what type of extraction. Extraction means, extraction is based on the basicity of the alkaloids and the fact that they are, already you know they are basic, occurs in the plants in a salt. On the solubility basis, the salts and water and organic solvents. Herbs often contain other materials which can interfere with extraction, such as substances by using emulsion or avoid defatting is very important. So defatting can be done by low power solvents using like hexane, petroleum ether. First you can remove the fats which may be hindering for the alkaloidal separation from a substance. So you can see extraction method normally depends on the raw material which you are selected and the purpose of extraction, the scale, what is the quantity and in which it is performed is very important. For a research purpose, chromatography allows a quick separation and relieve the result. For a large amount, the alkaloid need extracted by means of following methods can be used. Many methods, but still I have not mentioned here. This students should remember from this pharmaceutics: maceration, percolation, and there are various methods which can be used in large quantities can also be used. But hot percolation method is a very commonly used, and distillation is a very common use when you are going for volatile substance. This is just a TLC plate which I want to show you how they are identifying the compound by means of RF values, just a picture which is added. Extraction in an alkaline medium. You can see here, first step, powder the drug, pulverize the drug, or size reduction so that the area which can be easily solubilized and the extraction can be more. Size reduction is one of the subject which you might have studied in the pharmaceutics. Size reduction, increase the surface area so that facilitate the extraction process and support the extraction process. And the solvent can easily enter into the menstruum and solubilize the required active principle and to get. And defatting is very important. So defatted herbs removed, and first you defatted by means of using hexane or petroleum ether removed the fats and mixed with an alkaline aqueous solution, displaced alkaloids, and that salts combined, free bases are extracted with organic solvents. Normally, aqueous ammonia is used, and but the carbonated solution is used for alkaloid containing fragile elements such as esters or lactone. This is one common the thing which you can remember. In some cases, like cinchona bark, a mixture of calcium hydroxide, not oxides, calcium hydroxide and sodium hydroxide should be used, as the alkaloid are bound with to be tannins. So that can be removed by means of adding this calcium hydroxide and sodium hydroxide. Organic solvents like chloroform, dichloromethane, ethyl acetate depends on the toxicity, safety, cost, easy to recovery and recycling of the solvent. It will be selected by the researcher by the things which you want. And Soxhlet apparatus, which you can see directly in the lab, the industries, which is a continuous hot percolation method. This word which is not mentioned here, you should remember that. Continuously hot solvent heating from the round bottom flask, and the vapors will be dripped, and the siphon tube which siphons completely extraction may be taking place, and within 72 hours in a pilot extraction can be done. Large Soxhlet apparatus can also be used. Even industrial production also can be done by continuous hot percolation method by means of using stainless steel containers, large containers which you can use in herbal industries. So Soxhlet apparatus, you can see, this is the picture where you can see in the top there is a condenser, and the Soxhlet apparatus which is having a side tube and a siphon tube and a round bottom flask. Very clearly it will be explained in the book, and as well as if you see directly in the lab, like a mandel can be used, or the heating plate also can be used, like as shown in the picture. The side tube is very clear, and in between the side tube there is a siphon tube where the solvent accumulate and siphons and that come to the round bottom flask. And you can see very clearly the parts have been mentioned in the picture. Even you can see, you can get this picture in internet and in the book also. Round bottom flask, Soxhlet apparatus with a side tube and a siphon tube and a condenser, water condenser. Down you can see a hot heating source, maybe a hot plate, or you can say a mantle can also be used as shown in the picture. And you can see the video. This is not to show you the complete video for you, and you can see how this is the three parts which is shown in the picture. Round bottom flask, and this is the Soxhlet apparatus fixing method, and next one is they have a ground joint where you can fix the water condenser. So this, all of them will be fixed in a clamp as shown in the picture, like a heating mantle with a clamp. You have to fix with cotton should be kept, because borosil glass can break if you are not using cotton, for the soft cotton in between the clamps. And then this is the solvent system which is used in the side tube and a siphon tube, and you can see in the top there is the condenser which is fixed. The inlet will be from the water, and outlet also the rubber tube which is fixed there. You can see very clearly, this is what you can see, how the solvent which is dripping down, and you can see once it comes to the level and the siphon, completely the solvent system will be coming down. It is actually, you can see that how it is siphoning. So it is coming down to the flask, round bottom flask, and when you are using the solvent system, even the solvent system can be poured from the top also, and by the heating bandle it will siphon. That is what the rod by rod we are showing. That is the siphon tube where it is coming down back to the round bottom flask, and then again heating, and then the solvent system will go through the side tube, and then it will be recycled. This is just starting. You can see through the side tube the solvent vapors will pass through and go through the water condenser in the top, and then it drips down. You can see the condensed and hot liquid is condensing and falling onto the material which you kept in the Soxhlet apparatus. The brown color, you can see there is the material which you are interested to extract is kept there. That is Soxhlet apparatus. And once it comes to the level, and immediately it will siphon, and you can see it is the continuous oxalate method, how it will see it is siphoning completely, it will drain down, and again the new solvent will pass through, and this will be continuous oxalate apparatus method, which you can see. So that's what an extra. In the step 2, you can see the organic solvent containing alkaloid bases are separated from residue concentrated by distillation method also, under pressure, vacuum, and low pressure. When you are controlling, even the water can boil at 35 degrees centigrade to 40 degrees centigrade. 100 degrees centigrade needed, but still when you create vacuum, pressure control, vacuum creation, the solvent is turned in an acid aqueous solution, alkaloid goes into the solution as a salt, impurities remain in an organic phase, repeated until the solvent phase no longer contain alkaloids. So the many acids can be used, like HCl, sulfuric acid, citric acid, and tartaric acid. That is also organic acids, can also be used in dilute 1 to 5, so it can be used. And third step, the aqueous solution of alkaloid salts are washed with an apolar, that means an hexane, very low polar solvents, hexane, petroleum ether, which you should know that low polar, and alkalized with a base using an organic solvent not miscible with water, alkaloid precipitate and dissolve in organic phase, and extraction of an aqueous phase continues till all alkaloids have moved to an organic phase tested, and the Mayer's test on the aqueous phase becoming negative. So the purification step may be carried out by a various separating funnel, which can be used as a centrifuging separator or separating funnel. This I have explained in the classroom. What is a separating funnel and what is the use of centrifuging? This all you should see in the lab. Then only you can remember how it is separated in the third step. Some of the solvent system which can be removed, the use for removing alone the step. And final step, removing the solvent system, only the alkaloid, the organic solvent containing alkaloid and be that is decanted, or you can feed water and traces and anhydrous salts of sodium sulfate can be used or evaporated under reduced pressure and dried residue. This is one example of kava powder which is prepared. Like that you can get a very fine powder. And there are alkaloids extraction in the two method possible, pulverizing even acidic medium. This is basic medium previously. Acidic medium directly also it is possible, and extraction acidic, alcoholic and hydroalcoholic solution. This is also often distillation under vacuum pressure. Distillation can be done in some cases. So distillation process which we know, which we have studied using very simple distillation for an volatile alkaloids or nicotine alkaloids can be undergone by this method, is possible by distillating, and then by by separation can be seen. In both the case, results of aqueous solutions, alkaloid salt needs purification. So purification achieved by alkalizing the solution, extraction bases with an immiscible organic solvent, and it can be removed by separating funnel or centrifuging and absorb the alkaloids contents in it. And even you can use ion exchange chromatography by using a specific resin to attract the cation or anion which elute the strong acid and precipitate the alkaloids by iodide mercurides, like you are using Mayer's reagent, Dragon Draft reagent and Hager's reagent and even Wagner's reagent. These all are iodide, can be used for in ion exchange. Resins can be used by means of removing the cation anion resins. This is a picture just to show you. So you should know what is a chromatography and what is an ion exchange chromatography, how it can separate the alkaloids. Purity of an alkaloid can be done after an extraction. This is called isolation of extraction. Isolation of alkaloid, The all methods of alkaloid extraction yield a pure compound. So therefore it is separated by TLC, and that means thin layer chromatography, and HPLC, high performance liquid chromatography. These all classes separately I have given in my channel. It is possible for you to study about chromatography, thin layer chromatography, paper chromatography, HPLC. These all things individually the students have to listen to the classes so that you will get a good idea about chromatography, how it is used for separating the compounds. So alkaloids can be used for chromatographic technique and crystallization, and you can get even different types of crystals can be obtained by means of using both alkaline method and also acidic method. Isolation of alkaloids have large scale extraction, maybe in factory size purification like cinchona, coca alkaloids more used, and separation of final purification may be used by fractional precipitation, fractional crystallization can also. Chromatography is a technique most commonly complex alkaloids, common alkaloids and volatile oils like distillation for nicotine can be used, and very important insecticide most commonly which is used, tobacco plants can be used for manufacturing, and these all are isolation which you can remember. Pharmacological action and uses, I have added some of the example like CNS stimulant, caffeine, depression, you can see morphine, CNS sympatholytic or sympathomimetic, ephedrine, and sympatholytic yohimbine, ergot alkaloids, parasympathomimetic, pilocarpine, anticholinergic or parasympatholytic, choline, and gangliolytic like nicotine, and also local anesthetic like cocaine, and defibrillating agent or anti that is for example rhythmic of the heart can be controlled by means of antifibrillating agent like calcium channel blockers, and there are many drugs, but quinidine is also having this anti-arrhythmic drug, anti-tumor agent like ellipticin, an anti-malarial quinine, antibacterial berberine, and amebicides like emitin. So you see the lots of pictures just at Berry, there are many, but we have discussed most of the names. Listening very important and to write, and we have to see these all alkaloids, there are many, but selected alkaloids like vinca, ravalfia, belladonna, opium, ephedra, cinchona, datura, nexomica, and ergot and curchi. So these all alkaloids, some of the alkaloids which is possible in the next class, we will have a discussion. Individual alkaloids, what is the constituents present, what is its what's the part of the plant which contain alkaloids, how it is microscopic, these all things, and biological source as I have told, that is very very important, and pharmacological action, and if possible the student have to know about our own very famous Ayurveda, Siddha, Unani, which is having lots of drugs which is available, formulation which is available, need more professionals for using clinical affairs. So Pharm.D students can contribute their study in herbal formulations, what is its therapeutic activity, use your knowledge, update your knowledge, study well, and all the best for the next class. Thank you very much. Again I am repeating, subscribe my channel, and if you have any doubt, mail me, call me, and WhatsApp me in this number. It is possible for you to get a proper guidance according to the subject. Thank you very much. Sri Krishna College of Pharmaceutical Sciences, all the students I repeatedly saying, listen to the class and spend some time by listening the words of the language, very important for you to write in the exam. Thank you.